Hello, this is Brad Tallis with NexGenSolutions, and welcome to this week's Fusion Friday. This week's video is figuring out how to cut square tubing at the correct angle and the correct lengths. So let's take a look. So this example came from a viewer where they were asking, how could you go about creating square tubing with the correct angles and finding out the correct lengths and locations to cut the notches into the tubing to be able to bend it and weld it together for like a small garage or like a greenhouse or something like that. So there's a couple of different ways we could go about doing this. I'll show two different methods and hopefully that will give you guys some ideas on how you could go about doing this. So I'm going to start out by doing the tubing as like a sweep command. So I'm going to start by creating a new component and I'll just call it frame. Let's create a sketch on the front and I'm going to use the polygon command in this case because I want a certain number of straight segments. So I'm going to do the polygon command. I'll click here in the center and you can see that it's going to create, in this example, a 6-sided polygon. Well, I want it to have 12 sides total. And so now you can see there's more edges. And then I'm going to hit the tab key to go to the height. And I want this to be like, let's just say 7 feet tall. So I'm going to type in 7FT and it made it 7 feet tall or 84 inches tall. Now I only need half of this, so I'm going to just draw a line kind of through the center here. And then I want to get rid of all of these other lines, and I'm going to use the trim command for this. And here's a neat little trick not a lot of people know about, is if I just click on a line, it trims it, right? But that would take a lot of time clicking on each individual line. But if I click and drag, I can paint away the line. So I'm just holding down my mouse key and my mouse button, and it's trimming away all of those lines. And I'm left with this shape here. So I'll go ahead and finish my sketch and create another sketch because this is the path that the profile is going to follow. So I'm going to create another sketch on this top view. And I'm going to rotate just a little bit so you can kind of see what it looks like isometrically. And I want to project this point right here because we're going to capture to that point. And I'm going to do, let's just say 4x4 tubing. So I'm just going to draw a rectangle out here in space and let's make that 4x4. Now I want this to sweep along this edge here. So I'm going to say midpoint of that line to that point. And you can see how it's constrained it. The middle of this edge here is right on the start of this path. Now I know that I'm going to end up creating a hollow shape and using the shell command. So I'm going to go ahead and fillet the edges in the profile in my sketch instead of in the sweep command. So let's just go ahead and do 0.25 for all the corners here, like so, and I'll finish my sketch. Okay, then we'll use the sweep command. So I'll go to the create, sweep, what's the profile? I'll select that as my profile. What's the path? And you'll notice chain selection is turned on. So when I click on that, it's going to use that profile and sweep it along that path. And I'll go ahead and say OK. Now you might be asking, why did I put the profile on the inside of the path? And remember I said I wanted it to be 7 feet tall. So I know that from this face here to this face here is 7 feet tall. If I had done a center rectangle, then it would have been actually taller than 7 feet. Okay, so now I have this shape here. I'm going to go ahead and shell it out. So I'll use the shell command Let's just make it 0.125 thick. And I'm also going to select this other face over here. And we now have a hollow solid tube. Okay. I want to know what these angles are, and I want to break these down into like individual pieces. And there's actually a couple different ways of doing this. The first way is we need to kind of like split these into individual segments. But to do that, I need to have a splitting plane. So if I go into my construction menu, there's an option here, plane through two edges. And I could pick, for example, this outside edge and this inside edge, and it's going to create a plane that slices right through there. Then I could come in and use the split body command. What's my splitting tool? That there. I'll say OK. And we now have two separate bodies that we've split apart. However, this method is kind of time consuming. I have to kind of rinse and repeat, right? So I'm going to have to come in here and say through two edges, pick that edge, pick this edge, and do the split body again, over and over again. So this works, but it can take quite a few mouse clicks to get that to do what you want. So there's another method. So I'm going to undo back. So we're back to just a single body, no planes or anything like that. The other way is to use sketches to split. So I'm going to go ahead and create a sketch on this front face. And I'm just going to draw a line that goes to that point, like so. Then I can create a circular pattern of this line. What's my center point? That's going to be right there. And it's trying to do, 360 degrees. That's this full. I'm going to change it to partial, and that's going to do 180 degrees. And then I can just increase this and to the quantity of 7, and you'll notice that all of these lines are going right through these intersections, basically, with an extra line right here. I could suppress that if I want to by just turning on suppression and unchecking it. And I'll go ahead and say OK. Now, there is a drawback with this method, and I'll show you what I ran into and how I resolved it. So I'm going to say, finish my sketch. Let's go ahead and do a split body. So what's the body to split? What's my splitting tool? So I'm going to go ahead and select this, and you can see that it's actually going to, slice through. I'll go ahead, and you notice it says splitting tool, and then in parentheses it has the S, so you could do one tool or multiple tools. So I'm going to go ahead and select this here, and now you can see that it's doing both of those lines. But as I continue on, I got an error message. There is unhandled intersecting tool data. Try without intersecting tools. And I was thinking, well, what's intersecting? Well, all of these points down here, all these lines are coming to one point. And so I kind of figured that must be what the issue is. So how I solved it is I basically want to get rid of this point down here. So I'm just going to create a circle. It doesn't matter what size it is. And let's trim all of these lines. So I'm just, again, holding down my left mouse button and dragged all over those lines. And now we don't have intersecting points. So let's try this again. I'm going to say split body. What's my splitting tools? I'll select that one and that one. Then I'll add this third one, and sure enough, you can see I don't get the error message anymore. So I've selected all of those lines. I'll say OK, and just like that, we split the body into individual parts. Okay? To me, that method's a little bit faster than using the construction planes and then using split body, over and over and over again. Okay, so now I have these individual parts, but I want to orient them so they're like straight. So I know what my overall length of this square tubing is. and I could kind of figure out where the notches are supposed to be. So I'm going to convert these bodies into components. So I'm going to right click on bodies and say create components from bodies. And we can see that these are all now individual components. Now what this allows me to do is I kind of want to unfold this. And this isn't a sheet metal part. These are just, individual components, and I kind of want to unfold them. So I'm going to use as-built joint. And what this is going to allow me to do, you'll notice the type is set to revolute. By default, it might be set to rigid. I'm going to just change it to revolute. What are my components? That component and that component. Then it's asking for a snap point. And I'm just going to hover over this line. And I want to make sure I get the line and not the face, right? So I'm going to click on this line, and it's going to basically rotate on that axis. And then I'm just going to repeat this over and over again. So I'll click that point there, say okay, that guy. Okay, so we just created as-built joints. In fact, it's kind of fun if I grab onto this, you can kind of see how they're all linked together, but we want to make them all straight with each other. So I'm going to use the align command. What this is going to allow me to do is I can pick, for example, this flat face and this flat face, and it's going to align those together, but it's also using the as-built joint, that revolute joint, to keep those touching. And I'm just going to keep repeating that. I'll just say this flat face here and this flat face here. And then finally this last one. And now this is all one straight piece of pipe. I could go ahead and capture the position of this. We could do measurements. I could inspect how long is it from one end to the other. And then I could even create a drawing. So we can see that's 270 inches. We could create a drawing of this and dimension the distances between the notches. And we could even inspect the notch. Let's just measure from that face to this face. And we can see that that's an angle of 30 degrees in this case. So that's one method of doing it. The other method is to use sheet metal. So I'm going to go ahead and create a new design here. We'll jump into the sheet metal tab and create a sheet metal component. I'll call it frame. And I have a sheet metal rule called steel 0.125. That's what I'm going to go ahead and use. And we'll do the exact same thing. We'll create that polygon. We'll do the 12 sides just like we did last time. I'm going to zoom out here a little bit. And the overall height we said is 7 feet. And I'll draw the horizontal line and trim what we don't need. So I'm clicking and holding. I can just kind of paint away what we don't need. Now, believe it or not, this is all I have to do. I'm just going to say finish sketch. And in sheet metal, I can say create a flange. I'll just go ahead and select this flange. And I'll start to drag so you can kind of visually see what it's doing, but it's actually bending the material for us. I could tell it I want to go -4 inches in this case. And then I'm going to create flanges along the edge. So I'm going to click this edge here and this edge here. And I'll start to drag so you can kind of see what's going to happen here. But I want that height to be 4 inches because we want to basically do 4x4 tubing. I can continue clicking these top edges here, and because of this miter corners option that's checked, it's automatically mitering these corners for me. I'm not having to figure that out. So I'm just going to continue going along this edge like so. And we're left with something like this. I'll go ahead and say okay. Now, what I could have done, in fact, I think I'll go ahead and do this. I'm going to change my flange extrusion. Instead of -4, I'm going to say -2. And then I'm going to mirror this. So I'll go into Create, Mirror. I'll click on my sheet metal component. What's my mirror plane? I'll just click like this flat face right here. And this is pretty powerful. So I now have 2 separate mirrors. If I come back into my Solid tab and say Combine, I can select both of those and join them together. And we now have, in fact, I'll go ahead and remove this. We don't need it anymore. We have one sheet metal part. And this is a good example of, I got the exact same result where it gave me all these intersecting corners, and it took a lot less sketches. I only used one sketch in this case. I didn't have to split any bodies or whatever. And now I want to kind of like lay this out flat. So in the sheet metal tab, I can come in here and say unfold. Now, I'm going to select this as my stationary entity. And you can see bends, and then it says unfold all bends. If I say unfold all bends, I get this result. Okay? And that's not what I want. So I'll turn that off, and all I want is to unfold, for example, like that bend there, and you can see how it unfolds that bend. Well, here's a neat trick. I'm going to look at, so I'd have to click on each of these bends to do that. Well, that could take some time, so I'm going to look at the top, and when it's asking for the bends, I'm going to just draw a selection crossing window like so. And it's going to select all of those bends and unfold them all at the same time. So instead of me having to manually click 6 of them, it did it automatically. And I ended up with the exact same result as we did in this previous example. But I think with a lot less mouse clicks, and I think it's more accurate because it's actually showing, how the metal is going to deform, where does this peak need to come to, whereas the other one, it's basically rotating around a singular sharp edge, like right up here, for example. So to me, this is more realistic. Again, I could create a drawing of this, dimension that drawing, and get the final result that I need. Hopefully you found this video useful. If you did, all I ask is that you give the video a thumbs up and share or repost the video with others in your network. This will help spread the knowledge of Fusion out to the community. If you have any comments or ideas for future topics, please reach out to me at bradtallis@nexgensolutions.com, and I look forward to seeing you on the next Fusion Friday.